So with a median of 83% and a mean of 80%, you've done really, really well. So I think only three students actually failed the test. Okay, so it looks like these students here who scored in the 40s, 50s, and 60s didn't actually do the practice test, because I'm sure you will have seen that there's a significant overlap between the practice test and the class test. So that probably explains the 80%. Okay, so that's a general overview of the results for class test 2. I want to go through a few of the questions with you, some of the questions that some of you found particularly difficult. And then I'll show you the mock test, the practice test, and we'll talk through some of those questions as well. Let me I want to go through some of these questions together, just because I wasn't too happy with some of your answers. So for example, here on this question, there are a series of questions all looking at these bit error rate curves. Okay, so for bit error rate performance, you have a series of curves that generally look something like that. So as the signal to noise ratio improves, the bit error rate decreases. A bit error rate obviously is something we want to be very, very small, because bit error rate is the ratio between the bits in error divided by the total bits transmitted or received. Okay, so in this particular question, I think there were 3 of these. So in this particular one, we're told about amplitude shift keying. So for the graph, we're looking at this ASK. We're looking at that graph. Okay, we're not looking at any of the others. So it says look at the ASK curve, because we're only using ASK. Now, the important piece of information is this, the 12.6. 12.6 tells you what the signal to noise ratio is. So your signal to noise ratio, or in this case, it's called EB to N naught, is 10 log 10, the signal power divided by the noise power. They're telling you that the signal power is 12.5 times, or 12.6 times the noise power. So you're given that number. So it's simply 10 log 12.6. And that gives you 11 decibels. Now, the numbers you had in your test might be different, but in this case, we're looking at 11 decibels. So you're looking here, where you see decibels, you're looking at that line there. So you're looking at the intersection of your ASK curve with the 11 decibels. So you read that off against the horizontal axis, and you end up with a bit error rate of 10 to the minus 3. So this bit error rate is 10 to the minus 3. That means 1 bit in every 1,000 is received in error. So if you had 1,000 bits, you'd have 1 bit that was in error. So a 1 received as a 0, or a 0 received as a 1. So the question gives you more information than that, actually. The question actually says, look, we have a data rate of this much, we have a duration of this much seconds, and it says how many bits would be in error. So we're looking for this number here. So the number of bits in error would be equal to the total number of bits multiplied by the bit error rate. So the bits in error is the bit error rate times total number of bits. And the total number of bits is simply the bit rate, or the data rate, times the duration in time. So you can do the maths on your own. So that's 3.2 times 10 to the power 6. And you've got the time there. You multiply those, then you multiply it by 10 to the minus 3, and that will give you your number of bits in error. Okay, so most people got this question right, but a significant minority got it wrong. Now, there were a few questions where you had to explain, okay? So these explain questions, I put these in to prepare you for the final exam. So the final test will have many questions where you're asked to explain. Now, you're lucky in this question, all you needed was one sentence, maybe two, but in the exam, you'll have to explain in some detail. So it says, explain briefly why this is the case. What's being described is someone with a computer, and the computer is connected to a printer. And the question is, how come there's no sampling or quantization and no reconstruction? So there's no sampling here and there's no reconstruction here. Now the question gives you some information. It says, look, we're using USB 2 and the data rate is 480 megabit per second. Now you really need to be careful in questions like this. You need to look out for unnecessary information. You need to look out for things which are there to distract you. Okay, so the fact that the data rate is 480 megabit per second and we're using USB 2, that's unnecessary. That doesn't matter. You ignore that. The question is asking, why is there no sampling and why is there no reconstruction? Now, some people had some very strange responses to this, saying things like there's an anti-aliasing filter, and because it's sampled at a very high rate, or because there's no interference, or because we're using a cable. It's really very simple. We only need sampling and quantization if we have an analog signal, and we only need reconstruction if we want to reconstruct the analog signal. Right? So that's the only reason we would need to sample. And that's the only reason we would need to digitize, is if we want to convert an analog signal to a digital signal. In this case, we have a computer at one end and a printer at the other end. The data is already digital. And you're transmitting it to a device that is expecting digital data. So if you have digital on both ends, you don't need sampling. There's no need to sample. So the only thing you needed to say to get the full mark for this question is the data is already digital. That's all you needed to say. Another question that asks for an explanation is this one here. And again, you need to look out for unnecessary information. So what's it describing? It's describing a residential computer user. So someone has a computer and they connect to the web. They do that using a modem but the modem is also functioning as a router. So it's a two-in-one device, a modem and a router. And they're telling us, the question says, that the download rate is 5 megabit per second. So this rate from the cloud, from the internet to the router is 5 megabit per second. Okay, that's a maximum. And the user can connect using either Ethernet at 10 megabit per second or Wi-Fi at 54 megabit per second. So the user can connect to the router using Ethernet at 10 megabit per second, or by Wi-Fi at 54 megabit per second. So this particular user chose to connect using Ethernet. And the question is, why? Why use Ethernet when you have Wi-Fi available? So why settle for a lower connection speed when you have a higher connection speed available? Okay, so watch out for unnecessary information. It doesn't matter what this protocol is called. That's unnecessary. That doesn't matter. The only thing really that matters here is the lowest data rate available, the 5 megabit per second. This is what we call the bottleneck. Okay, this is what determines how fast the user can download information. So the rate of download from the web to this person's computer is determined by the lowest of the two speeds. So even if he were to connect using Wi-Fi at 54 megabit per second, he's unable to download data at anything higher than 5 megabit per second, because that's the bottleneck. Okay, so all you needed to say in this question was that we have a 5 megabit per second bottleneck, or something like it's not possible to download at a rate faster than 5 megabit per second. Therefore, the 10 megabit per second Ethernet connection is perfectly fine because it'll be operating at 5 megabit per second. Now, there are other advantages for using Ethernet. Okay, so Ethernet, probably less interference, less vulnerable to noise, more stable. That's fine. You can mention that, but these are secondary reasons. These aren't the main reason. This isn't why you would use Ethernet. So the question says, explain why this choice may be justified. So for full marks, all you need to do is to mention the bottleneck. It's to mention the 5 megabit per second. If you mention an advantage or some advantages of wired connection over wireless connection, you get most of the mark. I gave 4 out of 6.5 for mentioning the advantage of wired over Wi-Fi. But for the full mark, all you needed to do was to mention the bottleneck. If you mention both reasons, again, you get full mark. Okay. Any questions about that? Anyone want to comment on that? You feel free to interrupt me at any time. Okay, this was an easy question. I thought it was an easy question. Some people got it wrong. It was simply a case of matching. So you've got your Nyquist sample rate, and that is twice the baseband frequency. So that's F. The quantizer step size. Now, a digitizer step size is related to the number of bits. Okay, so your step size is your dynamic range divided by the number of levels, which is 2 to the power n. So that's this one here, C. The maximum quantizer error, now your error is related to the number of, it's related to the range and the number of levels. So your error is equal to the range divided by, well, it's equal to basically step size divided by 2. Okay, so if you have a range of that much and you have a number of steps, then your quantizer error is half of that. So it's the step size divided by 2. So it's range divided by 2 to the power n times 2. So it's that. So it's half the quantizer step size. So E. Last one is the data rate of a signal sampled at Fs using L levels. Okay, so if you have L levels, then n is log L to the base 2 and use a ceiling function. That means we round up to the next highest integer. So it's the closest to it is actually this, but it really should have looked like that. Okay, so that's your B. Okay, any questions about that? Any comments about that? This question is about frequency division multiplexing. So we have a frequency axis and we have a number of radio stations. Okay, each, how many radio stations? 5. So we have 5 FM radio stations. And the question is, what's the total bandwidth? How much bandwidth is required? So the question is, how much frequency do we need from here to there? What's the total bandwidth of all of these channels together? So that will depend on the bandwidth of each of these channels. So each of these will have its own bandwidth, okay? And in this case, they're not the same. So each of these have unique baseband bandwidths. So 1, 2, 3, 5, 1, 1, 5, 6, and 5. Okay, that's strange. It says 5 channels, but it looks like there are 6. 1, 2, 3, 4, 5, 6. Okay, so there's an error in this question. So we need to fix that. But basically, you would calculate the bandwidth using Carson's rule. You're given that beta is 6.4, so the bandwidth is approximately equal to 2 to 1 plus beta times the baseband bandwidth. And then you'd need to add your guard bands. So we're told that we have 1 kilohertz guard band between each of these. So you need to add, because there are 5 channels, you'd add 4 times 1 kilohertz. It's confusing here because it looks like there are 6 channels. I'll need to check the question, how it appeared to you. I hope you didn't see 6, but if so, I'll fix that. Okay, next question. Again, we have this residential computer user, and they're connected. So same kind of scenario. So you have a modem router, and that's connected to the cloud, and you have a download rate and you have, let's draw a little computer. You have either a Wi-Fi connection or an Ethernet connection. And the question is, what typical download speed would you expect the user to experience? And we're given that we have a 4.3 megabit per second connection here, up to 54 megabit per second here. No, sorry, up to 10 here and up to 54 here. So, does the user end up with that speed, or that speed for their download connection? So, again, we have a bottleneck problem. A bottleneck is where you have more than one connection as part of one communication system, and the overall data rate is determined by the slowest of these connections. So the numbers you got in your test might have been different, but in this case, we look at the lowest of these. So the lowest is 4.3. So the connection is determined by that. Okay, so if this, instead of being 10, if that was 3, then the speed would be determined by that. So in this case, we're not interested in that. We're interested in the 4.3 because that's the smallest. So to one significant figure, 4.3 is just 4. Okay, so that's the answer I'd expect for this. Okay, here, the next question is a pulse code modulation question. This time it's asking about images. We're given the resolution of the image. We're told how many bits per pixel, and we're told how many frames per second. So we have images, which you can think of as being a matrix of numbers. Each of these numbers we call a pixel, and each of these requires 24 bits. And you have a number of frames. In this case, your question might be different, but in this case, it's 7. 7 frames per second. Per second is important because the question is asking to find the bit rate in megabits per second. So in every second, we have 1064 times 579, that's the number of pixels, times 24 bits, times 7. Because they want it in megabits per second, you divide by 10 to the power 6. So, there's a question, how to answer download speed question, taking the lowest download speed when bottleneck is never mentioned in lectures. Okay, I did mention bottleneck in lectures. We mentioned this in the last 2 lectures. So bottleneck is where you have the lowest connection speed in a communication system where you have multiple links in series or in cascade. So the bottleneck is the slowest, the weakest link. Okay, you can't communicate faster than the slowest link in your connection. Okay, in your communication system. So someone is sharing a picture. Okay, someone's asking for feedback on a question. I can't give you that right now, but I can't even open the image for some reason. But if you post your question on the discussion board, I can give you feedback on that particular question. So I can see you're asking about question 13, but I can't open it. Okay. If we get disconnected because of Zoom, just reconnect and it should be fine. Here we have an FM signal. So the question is to find beta. So beta is a ratio, isn't it? It's your frequency deviation divided by your baseband frequency. And we're told that the instantaneous frequency varies to within 7% of its unmodulated value. So the unmodulated value, that just means the carrier frequency. Unmodulated means without any modulation. So that's by definition your carrier frequency. And they're saying that the instantaneous frequency varies to within 7%. Okay, you might have a different number in your question, but it's within some percentage of its unmodulated frequency. So the instantaneous frequency can be as high as 7% of the carrier frequency, or the unmodulated value. So you can just substitute the values and find beta. Most people got that answer correct. This is a longish question. It looks tricky. Again, I think this is a bottleneck question because you have multiple links, okay? So we have a geologist in the field gathering data. Again, we have unnecessary data. So this is unnecessary data. This doesn't really matter. The frequency of the device he or she is using doesn't matter. So let's focus on the actual connection links. We have a radio link, we have a Wi-Fi link, and we have a wired link. Okay, so you have these three. We have a fourth link. We have the actual satellite phone. So you've got 4 connection rates. And we have information about the data. And the question is, find the time. How long would it take to upload this file? Okay, so again, it's a bottleneck problem. We need to determine which of these numbers actually matters. Okay, so let's imagine you have your geologist and you have your sensor, which in this case is a radar, and that's connected to a computer, and the computer is connected to a portable router. So the field computer is connected to a router. The field computer is connected to a router by Wi-Fi. The router is connected to a modem using a cable, and the modem connects via satellite link to the ISP. So we have 1, 2, 3, 4 connections, each with its own connection speed. So here we have 576K. Here we have 4.2 M, 6.2 M, 201K. Now, in your question, you'll have different numbers. What matters here is the bottleneck. So we're interested in the lowest speed. So which speed will actually determine how fast you can upload your link. It's this link here. Okay, if the satellite link is only operating at 201, then it doesn't matter if we have 6.2 and 4.2 megabit per second. It doesn't matter, because you can only upload at the rate of the slowest link. So what matters is this, okay? We're interested in the 201 kilobit per second. And we're told the size of the file, it's 5 megabytes, and we're asked for the time, okay? So your time is equal to the size of the file divided by the data rate. So the size of the file is 5, and because we have this capital B, we're using bytes. So that's 8 bits. So 5 times 8 times 10 to the power 6, because we have a million here, the mega. And we're dividing it by the slowest link, which is 201 times 10 to the power 3. So that's your answer. You divide that, and then you divide by 60. It says to the nearest minute. So you divide by 60, and that will give you your answer there. Okay. Any questions about that? Okay, so this was maybe one of the hardest of the questions, because you've got multiple links. You need to use the data rate or use the bottleneck to find the data rate and then to find the amount of time. Okay, so that's all for the class test. There were some other questions, but most of you got those questions right. I focused here on the important questions. Now, I want to spend a little bit of time just discussing with you the class test. Okay, oh sorry, the exam. And in this case, we're talking about the specimen paper. Okay, so this is, if you like, a mock test. Okay. Now, the mock exam resembles the final exam. Okay, in terms of the format. Okay, so this is what it'll look like. It'll look like a normal exam. You'll have 4 questions, 1 to 4. Each question will be 25 marks. Okay, and each of these 25 marks will be broken down into sections. Okay, generally these sections will be multiples of 5. Not necessarily, but instead of having 5 marks for each section, as I normally would for this exam, this time you have some 5s and some 10s. Okay, so that'll give you an idea of how much time to spend on each section. Okay, so I don't plan to go through these questions one by one and answer them, but I want to talk you through how I would expect you to deal with these kind of questions. Okay, so some questions are pretty standard exam questions. So, for example, if you look at question 2C, have you seen this question before? Well, we have almost exactly the same question in a problem sheet. Okay, so just go back to the problem sheet and you'll find a question very similar to this. But as an extra, I asked for a frequency domain plot. So this you haven't seen. So this you have seen, this you haven't. Now, for most of the questions where I expect you to explain something, I tell you how much effort I expect. Okay, so use no more than half a page. Use no more than 300 words and 1 page. Okay, so that doesn't mean 1 page plus 300 words. It means either 300 words or 1 page. I don't expect more than that. Does that mean that you're not allowed to use 301 words? It doesn't mean that, no. Does that mean I expect something close to 300 words? No, it doesn't mean that. It just means that I don't expect 50 words. Okay, I expect a satisfactory explanation. So here you need to discuss two approaches for demodulation of FM. So you're going to have to talk about both types, you know, zero crossing and the discriminator. Both of these will need a diagram. Okay, so you're going to have two diagrams, and then maybe 2 signals or 3 or 4 signals at each stage of the block diagram, and then some explanation, maybe 50 words for each of the blocks, or 10, 20 words for each of the blocks, and a little bit of mathematical explanation. 1 page should be enough. Half the page for the first, half the page for the second. Is it okay to copy from the lecture notes? Okay. Is it, or do you think? Do you think it's okay to copy from the PowerPoints? If it's a standard question like this, that's already available in the PowerPoints, is it okay to just copy? What do you think? And by copy, there's 2 things you can copy. It could be a diagram or a figure, or it could be text and maths. Is it okay to copy? Well, it's not a simple answer. Okay. If when I say copy, if we mean copy as in copy and paste, electronic copy and paste, so you pick up from the PowerPoint and you paste it in your answer, then that's absolutely not acceptable. Okay, you'll get a 0 for that. So if you pick up content from the PowerPoint or from any other source, okay, any other source, if you find a figure on the internet that you think looks really good, and you pick it up, copy and paste, and then you put the reference, you put taken from reference 1, and then in the references, you put the reference. It's still not acceptable, okay? So you get a 0 for that. You're not allowed to copy from any source, okay? Because it's an exam. If you were in an exam room, under examination conditions, you wouldn't have any other source that you can copy and paste from, okay? So that's for electronic copying. So electronic copying, no. But if it says, you know, illustrating and describing in as much detail, so you're going to want a block diagram, okay? And the block diagram is available in the PowerPoint. So you're not going to make up your own block diagram. You will be presenting the block diagram from the PowerPoint. So if you draw your own, from the PowerPoints, that's fine. Okay, so if you copy it yourself, that's fine. Will you get a full mark for doing that? What do you think? Well, if the question was so easy that you can just copy it from the PowerPoints, there wouldn't be 5 marks, okay? It's an open book test. So in this question, you would need the block diagram, but you'd also need to explain. And it's the explain that will carry most of the marks, okay? Now, I was talking about figures. What about text? If I ask you to explain something and you just copy text from the PowerPoint, I won't consider that to be you explaining. I will consider that to be you telling me what I told you. You're just copying what I told you. So that's not acceptable. You need to explain it yourself. Okay, so you need to use your own language. Okay, so I'm not making it difficult for you. I'm trying to make it as easy as possible to do well in this test. So each of these questions I've written in such a way to make it really easy for you to do well, even if these questions look difficult to answer. Now, will I be answering these questions for you? No, I won't. But I will give you feedback, okay? So if you, there's two feedback routes, okay? If you post your ideas or your solutions on the discussion board, I will respond. I will give feedback, okay? That's one route. Another route is to upload solutions to Turnitin, okay? If you upload solutions to Turnitin, I will give feedback. Okay, so you can post your solutions, your ideas. It doesn't have to be for the whole question, the whole exam, or the whole question. Even if it's just part 3, question 3, part A, you can say, this is what I think the answer is. Is that enough? And I'll respond. I'll say, no, that's completely wrong. Or I'll say, that's correct, but it's not enough. Or I'll say, that's correct, but it's too much. You can express it in fewer words. And it says, use no more here, for example, than half a page. Okay, so that gives you an idea of how much effort I'm expecting. So use the discussion board, okay? And the discussion board doesn't mean that you post and I respond. That's not how the discussion board works. The discussion board is for all of you. So one person can post a question, another person can post their idea, a third person can suggest another idea, someone else can combine the two ideas and put another answer. I'm perfectly happy for you guys all to have a group discussion and to share your ideas and to effectively cheat on the practice test. That's absolutely fine, okay? Some of these questions from the mock exam are very similar to questions in the final exam, okay? So the mock exam doesn't look like the final exam. It's not the same questions, but some questions will be very similar. So if you're able to answer this exam paper comfortably, you should be okay with the final exam. So you'll see some questions are less familiar than others. So if you look at the first question, it's saying, why is the internet backbone using cables rather than wireless, okay? So you need to think, for 5 marks, you're not going to be using many words. So it's just 200 words. That's less than a page. So in that page, just explain, why do you think the most important parts of the internet rely on cables? Why not wireless? Okay, so you need to think about some of the advantages and disadvantages. Focus on things like data rate, vulnerability to noise, etc. Okay, many questions, or at least several questions, so more than one question, will involve design, okay? When you're asked to design something, sometimes you're not given any numbers. So for example, look at this question here. For 10 marks, there's not a single number. And many people are uncomfortable with that, okay? If you don't have numbers, how do you answer? How am I going to design an analog radio talk station if I have no numbers? What's the bit depth? What's the sampling rate? So you're used to questions where I give you everything. I give you all the numbers, and you just have to put those numbers into a formula, okay? In this open book exam, there will be some numbers given to you, but sometimes what you're given is quantities. So you're given Fs, Fc, B, N, and you need to derive an expression. Sometimes there are no numbers at all. So you need to choose. That means you need to choose parameters. And how you choose them is really important. So you need to choose suitable parameters. And this suitable, that's what makes it a design exercise. You need to be able to select what parameters are suitable. Okay, so this suitability comes down to things like constraints. It comes down to things like the nature of the data. So for example, what do we know about the nature of voice data? We know the nature of voice data is that the frequency is generally less than 5 kilohertz. What do we know about audio data? Audio data can be up to 15 kilohertz. Constraints, that could be data rate constraints. It could be something like the channel capacity. Okay, that's a constraint. A bottleneck is a constraint, and there are other constraints. So when choosing a suitable parameter, you need to think about the nature of the data. You need to think about constraints. You need to think about, so another constraint is other considerations from the question itself. The question might give you constraints, other considerations from the question. So looking at this question again, we're told that, for example, you have an analog television station. Okay, so two things, analog and television. So television, that tells you that it's likely to be VSB. Okay, so analog TV, it's likely to be VSB. What does that tell you about the bandwidth? The bandwidth is going to be in the order of 5 megahertz. Let's say you don't know the 5, it'll be in the order of something megahertz. 2 megahertz, 10 megahertz, it doesn't matter, but it's not going to be kilohertz. Okay. For part 3, we're told that there are 20 stories in an apartment building. Okay. So you need to give a realistic assessment. How many flats per story? What's a realistic number? 1, 2, 50? What's a realistic number of flats per story? You need to come up with that, okay? That's what a design exercise is. So let's say you assume, that there are 6 flats per story. That's an assumption, okay? You might assume 5, you might assume 8, you might assume 4, but you need to justify, you need to say, assuming that we have 20 stories and assuming we have 6 flats per story. 6 times 20 is 120. And the data rate for each cable or each channel or each flat or each story is such and such based on an audio bandwidth of such and such. You do the multiplication and you come up with a design. It doesn't have to be a perfect design. It's not going to be the best design. It's not going to be the same for all students, but it has to be a justifiable, realistic design. Okay, the same with this question here about a 4G smartphone. So you need to have some idea about 4G data rate, some idea about what the resolution of a camera will be. When it's a homemade security camera system, you need to be able to think whether it's a duplex or a simplex system. Is it just one way uploading, or uploading and downloading? You need to sort of include all your assumptions within that. And it says use no more than one page. So don't spend 2 hours doing this question. It's only 10%. So it's 10% of something like 3 hours. Okay, so it's not a lot of time. Okay, so use that to guide your answers. As I said, you give me an opportunity to offer feedback, okay, by either posting your suggestions, your answers, your solutions, your attempts, your designs to the discussion board, or posting it to Turnitin. Okay, so you have plenty of time from now to the exam to practice. Okay, I will try to give you as much feedback as I can, but I can only do that if you actually engage with the exam. So just like the practice exam was, I hope, or the practice test was a good preparation for your class test, and it looks like you did very well on that. I hope that this mock or this practice exam that I've uploaded will be a good preparation for your final exam. Okay, I've also uploaded some papers from previous years, and those will be useful, maybe not as useful as this exam, because the last one I uploaded is an open book test, and many people were asking for specific examples of open book questions. So I've tried to do that. I hope you find that helpful. I will be available again at the normal time. It's 9 o'clock on Thursday, and maybe I can answer any questions you have, and maybe go through some of this in a bit more detail on Thursday. Okay, does anyone have any questions? So someone is asking, does everyone have the same questions? That doesn't matter, okay? That doesn't matter. So at the moment, the practice test is the same. So the mock test I just uploaded, there's one copy of that. In the final exam, if you all get the same question or you get different questions, doesn't matter, okay? In some modules, it might be the same exam. In some modules, it might be different exams. In some modules, it might be partially identical, partially different. That doesn't matter, okay? We don't need to answer that. Any final questions before I go? Okay, I'm going to stop the recording. I'll upload this to Vital, and I'll see you all on Thursday.